This is Unit 3 Quadratics, Lesson 3.3 Introductory to Factoring and Greatest Common Monomial Factor. In this lesson, we are actually reviewing what I've already showed you in previous lesson of finding the greatest common factor and then factoring it out. So these objectives are all review. If you are looking at the teacher-led presentation, you'll notice that I'm going to skip over some of the slides because I do know that this is a review. So what is factoring? Factoring is a way of splitting up a polynomial into simpler terms. It's like reverse multiplying. Okay? So you're going to be finding out the simpler terms or factors that when you multiply together they equal the original polynomial. So we're kind of working backwards. If you recall, a monomial is just a one-term expression where a polynomial is two or more terms, or the sum or difference of monomials. One rule that we will be using when we're factoring is the quotient rule, so this should be a review. Remember that when you divide variables, you will actually subtract their exponents. So in this example here, so what do we do with exponents when we divide? We subtract just their powers. Or their exponents. So in the first example, 10 or x to the 10th divided by x to the 4th. This is just another way of writing it, and generally we will see it in that fraction form. You generally will not see the division symbol like this. Is equal to x to the 6th. I know you know how to do this, so I'm going to go ahead and skip down to the third example. X to the 9th over x. Just remember, if you see a variable without an exponent, its exponent is 1, so that would be x to the 8th. So if you recall, to try to find the greatest common monomial factor, you have to look at the coefficients of the polynomial that you're trying to find the greatest common factor and ask yourself, what's the biggest number that you know that divides evenly into all three of those coefficients? So 4, 8, and 12. The biggest number you can divide all of them by is 4. Then you look at the variables. And you ask yourself, what is the exponent or the smallest degree of the variables? Well, the smallest degree is x to the first. So your greatest common factor would be 4x to the first, or just 4x. Remember that if the leading coefficient is negative, you should pull out that negative, or your greatest common factor will be a negative number. If the leading term is positive, then your greatest common factor will also be positive. So let's find the greatest common monomial factor of these polynomials. Just again, review. 24, 16, and 12. The biggest number that goes into all of them, let's see, 6 goes into 24 and 12, but it doesn't go into 16. How about 4? 4 goes into 24, 16, and 12. 2 goes into all three of them, but because 4 is bigger than 2, 4 is the greatest one. And then our variable, there's an x in every term, so that's common, and the smallest exponent is 1, so 4x is the greatest common factor. In the second example, we have 42, negative 54, and positive 36. The largest number that goes into all three. If you're like me, sometimes I get stumped and I can't just think of them off the top of my head. So remember, you can write all the factor pairs down in order to determine the greatest common factor. So I'm going to do that real quick. 42, the factors of 42 are 1 and 42. 1 is always a factor of a number. 2 and 21. Let's see, 3 and 3 goes into 4 one time with a remainder, so 12, 14 times. 4 doesn't go into 42. 5 doesn't go into it. 6 does, 6 times 7, and there's no numbers between 6 and 7. So those are all the factor pairs of 42. I'll do the same thing with 54. Now I'm going to ignore for the at this point that it is a negative 54 and just use the 54. 1 and 54 are factors, 2 and, let's see, 25, 26, 27, 3 and 18. If you need to use a calculator on these, you can. 4, I don't know that 4 goes into it. Let me check. I got 13.5, so 4 does not go into 54. 5 does not go into it. I know it doesn't because it doesn't end in a 0 or a 5. 54 doesn't. 6, yes, 6 goes into 54 9 times. 7 doesn't go into 54. 8 does not go into it, and the next number is 9. So those are all the factors of 54. Then we can go to 36. The factors of 36 are 1 and 36, 2 and 15, 16, 17, 18, 3 and 12, 4 and 9, 5 doesn't work, but 6 does. 6 and 6, and there's no numbers between 6 and 6, so those are all the factors of 6. Now we need to look for the greatest common factor, so the number that's the biggest of all of them. Let me change my pen color here. Alright, so what I usually do was I'll look at the largest number here, the 42, and start looking down all of its numbers. So 42, is there a 42 in any of these? No. How about 21? No. 14? No. 7? No. 6? There's a 6 in my 42, a 6 in my 54, and a 6 in my 36. So the greatest common factor between all three numbers is 6. Now the next part is easy. There's a y term, there's a y variable in all three terms, and the smallest exponent is 2. So the greatest common factor is 6y squared. I think finding the greatest common factor of your coefficients is probably your hardest part, if you don't just see them. You have to really know your multiplication, division tables very well, frontwards and backwards, and know all the different combinations. Otherwise, you'll have to do the long way like what I just showed you. Okay, so how do you find the greatest common factor when there's more than one variable? You actually will do this in the exact same steps. Again, look at your coefficients of each one of the terms and find your greatest common factor between them. I believe 54, 81, and 63 can all be divided by 9. I don't think there's a bigger one in there. Then you would write down what variables are common in all three terms. Well, there's an x in all three terms, and the smallest exponent of the x is 1. You don't have to write that 1 there, but I'm just going to do it just so I acknowledge that I did look at my my exponents. And then notice that there's a y in every term. So y of, and then what's its smallest degree? Its smallest degree is 4. So the greatest common factor is 9x y to the 4th. Let's try another example. We have three terms. The coefficients of the three terms are 16, 8, and 12. 8 goes into 16 and 8 but doesn't go into 12, so 4 must be the largest or the greatest common factor of those coefficients. And then again, the variables that are in all three are x, and the smallest degree of the x is 1. But why can't I write y? Y is not part of my greatest common factor. Do you see why? Y is in my first term and my second term, but there's no y in my third term. Because there's not a y in every term, it cannot be part of the common factor. So 4x is the greatest common factor of this polynomial. So when you're factoring out the greatest common factor of a monomial, you can think of this as undistributing or reverse distributing. So we're working backwards. If you were to multiply 2x times the quantity x squared plus 4x plus 8, your result would be 2x to the third plus 8x squared plus 16. You'd use that distributive property. Remember when we took the term and you multiply it to each term on the inside? Well, when you're factoring, you're going to do the reverse. You want to know how did you get this? Okay, is basically what it's asking. So the way you would do that is you would divide the polynomial by its greatest common factor. So you take the polynomial and divide each term by the greatest common factor, which they figured out was 2x. Divide each term by 2x. So there's the greatest common factor, and then in parentheses you write the answer to that division. 2 divided by 2x to the third divided by x, well the 2's cancel out, and x to the third over x to the first equals x to the second. 8 over 2 reduces to 4, x squared over x to the first equals x to the first. And 16 over 2, well 16 divided by 2 is 8, and x over x would be x to the 0. So this just reduces to just 8. Some of you may put x to the 0 power, but remember that you do not need to write that. In fact, we prefer that you don't. Alright, so let's look at focus question 1. We are factoring out the greatest common factor of the polynomial 24x to the third minus 8x to the second. So you do it in 2 steps. First, find the GCF of greatest common factor of the coefficients. So 24 and 8, the biggest number that can divide into both, I believe, is 8. And the greatest common factor of the variables, well, there's a x in both terms, and the smallest coefficient, or the smallest exponent, I'm sorry, is 2. So we have an ax to the second as part of our answer. Now we need to know what is this polynomial when we divide by the greatest common factor. So 24x to the third minus 8x to the second. Divide each term by the greatest common factor we just figured out, 8x to the second. 24 over 8 reduces to, what, 3? X to the third over x to the second is just x, because you subtract their exponents. Negative 8 over negative 8 equals negative 1. I'm going to hold that thought for a second. Well, I could go ahead and write a 1 there. And then x to the second over x to the second, well, those cancel out because it'd be x to the 0. So there, you've just factored using greatest common factors. Let's try another one that has more than one variable. First, find the greatest common factor of the coefficients. The coefficients are 12 and 36. The biggest number that goes into both of those is 12. And then your variables that are common in both terms are y and z. The smallest exponent on your y is 2. The smallest exponent on the z is 8. So when we factor it out, the monomial that factors out is 12y to the second, z to the 8th. And now we need to find its factored pair. The way you find that, again, is you divide every term by the greatest common factor. So it's supposed to be a z to the 8th minus 36, y to the second, z to the 9th. So I'm just copying down the problem, and then I'll divide each term by the greatest common factor. Write it right underneath it. Second, z to the 8th, 12. Y to the second, z to the 8th, and reduce those fractions. So 12 over 12 is just 1. Y over y squared will cancel out. Z over z to the 8th over z to the 8th would also cancel out, so you just have the 1 there. Minus 36 over 12 reduces to 2. The y squares cancel out, and we have z to the 9th over z to the 8th, so that would just equal z. Just another example. Again, get good at these. 99, 81, and 36. The biggest number that goes into all three of those numbers is 9. The c is in all three terms, and the smallest exponent of c is 3. Variable term, there is a d in all three terms. And our smallest exponent on the d is 2. So our greatest common factor then is 9c to the third d to the second. And we need to find out what we had to multiply that by. So we divide the polynomial by our greatest common factor. 99c to the... Here, I'm going to probably do this up above. So I'm going to divide each one of these terms by the greatest common factor. So 9c to the third d to the second. c to the third d to the second. c to the third d to the second. Okay, 99 divided by 9 is 11. C to the fourth over C to the third is just C. D to the eighth over D to the second, that's D to the sixth. Just keep on subtracting. Plus, don't forget the plus and minus signs in between each term after you divide. 81 over 9 is 9. C to the third, C to the third, those cancel out. D to the sixth over D to the second equals D to the fourth minus 36 divided by 9 is 4. And, oops, I made a mistake here. Do you see the mistake? And I realized it when I got to that third term. Look at that third term, negative 36d to the second. I can't divide by c to the third, so therefore c to the third should not have been part of the greatest common factor here. So c to the third, there is no c that's common in between all three terms. So we're going to remove that off of our greatest common factor. That does change the whole rest of our problem. So let me erase and go back. I apologize for this. We need to go back. That's why it's very important to be careful on these. It's easy to make mistakes. So our greatest common factor, we still have the greatest common factor. The coefficients is 9. Our variable 1, which is c, there's not a c in all three terms, so c is not part of the greatest common factor. But there is a d in all three terms, and the highest exponent is 2. So our greatest common factor is 9d to the second, and that's what we need to divide every term by. 9d to the second, 9d to the second, 9d to the second. 99 over 9 is 11. C to the fourth, here that 11 didn't come out too good. C to the fourth, there's no c's below it, so all four c's stay. D to the eighth over d to the second would be equal to d to the sixth plus 81 over 9 is 9. C to the third divided by no c's is still c to the third. D to the sixth over d to the second is d to the fourth minus 36 divided by 9 is 4. D to the second over d to the second, that would cancel out. So there we factored out this polynomial. You can always check these by distributing and making sure that you get the original answer.